Hey everyone, welcome to the first edition of Build in the Cloud. We are very excited to be here to share about a topic which is very close to the heart. Google today is at the forefront of both of these topics, Gen AI and Web3. And all of us get to have a front seat at the cutting edge innovation happening here. This is the first in the series. We are all from the Web3 team, and we work with companies like yours to basically help and scale as you build out in this space, right? So for today, our basically before we go into the agenda, quick mechanics and housekeeping. For those of you who are joining this platform for the first time, basically, you will see a small icon on the right which has a triangle, a square, and a circle. That's basically the activity center. If you click that, you'll be able to see an option to ask questions. So feel free to post your questions there. We'll have time at the end for Q&A. You can also use the chat to post questions. That's a quick housekeeping for us to make sure that we are able to interact and keep the session interactive. Moving on, the speakers for today. So we have myself. My name is Pranav. I'm part of the Web3 team and specifically lead strategic pursuits and go market for APAC. Along with me is Abhishek Bhagwat. He's basically a global solution architect and specialist on AI and ML. And Adrian, who is also a principal architect with the Web3 team. So that's the set of speakers for today. In terms of what we are going to cover, we'll start with a quick overview of the Gen AI stack in terms of what we can offer. Then Adrian will guide us through a tour of the GenAI platform, showcasing you various capabilities that we have out of box. We have a very cool demo that Abhi has built. It's basically a natural language querying on the blockchain datasets. And then we'll move on to how Google can help you get started with some time for Q&A. So that's the flow for today. And now I'll pass on to Adrian, who will walk us through the overall stack and the platform as well. Adrian, over to you.
Thank you, Pranav. Thank you, Pranav. I think the very first thing that is very important to realize is that when we talk about Bard or ChatGPT and these kind of tools, right, they are not enterprise grade. And what we mean by that is that you don't have control over your data, you don't have IP protection, it's not grounded in facts with your data, it's not regulatory compliant, and so on, right? And so only in Google Suite, you will have that we're going to show you, right? We'll do the demo and so on. You can really build inside your tenant and you can control all of these points and data that are written here. Okay, so in terms of stack, right, and what we are proposing, this is the Google Cloud AI portfolio. At the very top, we have pre-built solutions for businesses, like business users. They are built with large models and Gen AI. Are very easy to use and can be basically used directly by business users, right? So we're not going to demo that today, but we are more going to focus on both Gen App Builder and also Vertex AI. So Generative AI App Builder is basically for the developers, right? We bring together the foundational models and we give them the workflow control of conversational AI and the really grounding in factuality of the Google quality search, right? So for example, if you're Binance, you need to make sure that the users' queries are not going to mention Coinbase, right? You can do that very easily using Gen AI App Builder, okay? So you can, for example, create a flow for payment, gathering credit card information, wallet information, identity information, and so on, right? And you can do that very easily, creating a pipeline. So if someone is asking, right, a factual question, I don't want the foundational model to answer, but I want the enterprise search to find the results using my docs or my website documentation or stuff like that, and then give these results to a foundation model, and then they are going to use it to summarize or come up with the answer, right? And that's very different on how it works. So to sum up, right, just recapping, the foundation model is the creative part, but I want to control it with my workflow. I want to ground it in factuality with my data and my enterprise search, right? And then at the bottom here, we also have Vertex AI, and we're going to show that as well. It's basically for AI practitioners. You can start with Model Garden to find first-party, third-party, or open source models, and then you can modify them, you can fine-tune the models, you can train them, distill them, create API access, and we'll see all of that. And you can do that in a very easy way. And of course, everything is built on top of GPU and TPUs of the Google Cloud infrastructure. Okay. So no one knows really where all of this is going, right? And that goes tremendously fast. But what we can see from what people are doing, our customers are doing, and even what we are doing as Google, there are really four areas that make sense. The first one is really that AI is really good at making huge amount of data searchable. So you can basically summarize, bring insight and trends in a time-saving manner, right? The second one is that every time a human need to interact with the machine, you can basically make it more intuitive and smooth by using natural language. And nowadays it becomes very hard, right, to say, if not impossible, to detect a human from AI, right? So really, you really have to think about customer service here. Right? The third area is every time you need content generation, everything text, image, video, music, even code, AI can basically maximize productivity. If you're a coder, you can have simple quick start. If you're a designer, you can have samples and you can get started easily. And finally, it's a bit more complex or a bit more long-term, but it's about AI practitioners. You can take a model, you can integrate them with the company data, flows, fine-tuning them, and so on, right? So we'll try to give examples of all of that. And if we translate, right, these use cases for Web3, this is kind of like what we get. So I'm not going to read over all of the data here, but I'll give a few examples. For the complex data, intuitively accessible use case, we can basically create services that can offer personalized content, right? We can offer synthesized market and financial research. It can also help prevent scams, analyze smart contract vulnerability. And one cool example is to find the best time to send transactions to have the lowest gas price possible. And we also, could imagine something where we can give recommendation on investments or new features that are available for a centralized exchange, for example, based on what transactions or investments of specific users have been doing. For the online interactions or like the customer support use case, it's pretty straightforward. We can have automated bots to help users and create tickets. And that's pretty huge, right? We have a lot of companies and customers using it this way. But you can imagine, for example, a centralized exchange that could recover the information they would need to refund a transaction that you mistakenly sent to the wrong address, right? So that's something that usually takes a lot of time. It's probably one of the the most submitted ticket for central exchange. And you could have, for example, a flow where the AI would get all of the information that they would need to get the information about the transaction, what chain they used, and retrieve the information directly from the chain to make sure that the transaction is there, and then creating a call to the microservice to trigger the refund if necessary, right? And if everything checks out. So that could be a nice use case. For the content generation, creating AI-generated NFTs is growing, but you can also really generate like code samples, smart contract templates, and stuff like that. We'll actually show you some examples of that in a few minutes. But that's basically what's possible to do. And we have we might in another call show you what our customers are doing, especially using, we have a company that is using Gen AI to generate the body of a PFP NFT, right? So a profile picture. So if let's say you have a Bored Ape profile and you want to generate a body in order to be able to play a video game, so it will generate the sprites and so on automatically. So that's a pretty cool use case that we might show you in a future edition of this core. Okay. And then I think for all of the use cases that are here, fine-tuning models based on blockchain data or smart contract data will really give you incredibly better results, right? And we have a few examples of that during the demo as well. But that's why the ability to have adapter layers and be able to test different models pretty easily, to fine-tune them, distillation also is very important, right? Okay. So a very quick slide here to talk about the architecture. It may look complex, but it's really not. There are basically two elements. The first one is the LLM, which is frozen, and that is stored in like the Google Cloud Central Hosting. And what's important to know is that this LLM is frozen, right? It doesn't store queries, it doesn't store user queries and stuff like that. It doesn't change, or it does not evolve based on the queries that are sent to it. And that's, I think, very important to realize, right? A lot of people think that, oh yeah, the LLM is evolving or changing. It's not. The LLM is stateless, right? So this is stored by Google. And then you have your tenant. And in this tenant, you will have everything else. You will have your data, you have the queries from users, you have the adapter layers with your own data and documentations and so on, right? And when your tenant talks to the LLM, of course, it's encrypted and no one can have access to this communication apart from you. And a side note here as well, that you can always deploy like open source models or your own models in your own endpoints in Vertex, running your own machines as well, if you want to. And if you want to have like your own task-specific LLMs, like Stable Diffusion or Llama 2, for example, right? All right. And so to recap, Google Cloud really provides the state of the art, right, in AI. It's been 20 years that Google is working in AI. Many of the tech underpinning the modern AI was actually invented by Google. And we propose not only first-party, but also third-party open source tools and models, such as LangChain, that is open source, that we'll show you in Abby's demo. We also have end-to-end governance, because model, yes, are important, but the platform is even more important. We provide you the means to control the whole lifecycle, from like ML ops to tuning and prompting and API deployment, pipelines, and so on, right? And so remember, right, like Bard, ChatGPT really are for consumers, and that's why I wanted to show during this small presentation here, companies need more enterprise-ready tools and services, and really to have control over all of what we've seen here. Okay, so with that said, we're going to give you a tour of what all of this looks like. All right, so let me share my screen. Okay, so I have a project here that was created. This is the Cloud Console. Sorry. This is the Cloud Console homepage, and in the menu here, what I can do is basically scroll down, and you can see that you have. So I pinned already the two that are interesting for us today: is Vertex AI and GenApp Builder, but you can find them in the menu below otherwise. And so I can just click on Vertex AI. We'll start with that, and that's basically what it looks like. And you see on the left here, you have a lot of different tools and menus. And so we're going to start with the model garden, right? So if you remember, the model garden is where you can find first-party, third-party, open source models, and so on. So you see here, you have Palm 2 for text, you have Llama 2, you have Claude 2, and basically you have a lot of models here. And what we can do is, for example, we can directly click here on the Palm 2 for text, and we can see here what it looks like. You have some examples of queries, and then you can open the prompt design, right? So from here, you can basically put any query, and you have the result. So I've prepared a query already. And I will open it and find it from here. Okay. I saved it. So the query is here. The query is basically asking the GenAI LLM to create a smart contract for an ERC20 of the Google token symbol GOOG. And when created, the owner should receive 1 billion tokens. The contract should be mintable, but not pausable. The contract should also have use roles. The contract should also contain a test to revert if there is a transfer of more than 100 GOOG tokens, right? The max supply for the token is 1 trillion. And so this query here, if I submit, you see a bunch of parameters on the right here. We'll not touch that for now, but then we'll show you a few things. But if I submit the query here, you see that we have the results here. So let me zoom a little bit. So this is the answer, right? And you can see that the reply is not so great, right? It doesn't have a supply cap as we but we did ask for it. It doesn't have the initial supply, right? It's basically just using it as a parameter. It doesn't use really roles for pause. It doesn't. So it's not, the answer is not so great, right? But let's look at what we can do, right? What we can do is a simple way to improve this model is basically if I go back to language here, I can go to my prompts and I saved an example. I saved an example of a structured query. And a structured query is basically, if I zoom here, you can see that there is a few examples of queries with the input and the output. And then you can query basically the same. You can ask a question and it will give you the answer based and helping the LLM with these few examples here. And so what I've done is that I've used OpenZeppelin contracts to basically be able to give examples of an ERC20 that is with an initial supply, an ERC20 that is mintable, an ERC20 that is pausable, and use the open source documentation, OpenZeppelin documentation to give the examples here. And so with that, basically few examples here, if I ask the LLM the exact same query with the exact same parameters to the same LLM, and I submit, then we will see that the answer is basically a bit better, right? We now have the initial mint, and we have the roles, but there is still no a max supply cap, right? And so that could be so it's not perfect yet. And so, but I gave it some examples, but it was still not able to figure out everything, by its own. And maybe some of you noticed, but what I'm using here is actually the text Python model, right? So text is basically the Palm LLM that we have from Google, and that is specialized in natural language, right? And if you know, we have different LLMs, and we have another one that is Cody, that is specialized in code generation, right? So we can use this one instead and see what it looks like, right? So if I'm going to use the same exact query without the samples, right? Without giving all of the examples with OpenZeppelin, and I'm directly going to query this one. And here the result is perfect, right? We see that we have a max supply, so you cannot mint outside of this. You have a mint automatically at the constructor for an initial supply for the owner of the contract. We have the roles, we have everything, right? And so I think this is a very good example that shows that the importance of a model, right? If you use a text model for code generation, you won't have very good results. You might have good results, as we've seen, right? We can make it work. But if you use code Bison instead, you don't have to do anything, right? So it's really important. And that's really why you should be careful when you want to use it for your business, that you cannot just query Bard API or ChatGPT API and think that you'll have great results, right? You need fine tuning. You need to really figure out your use case. Maybe you can distill your LLMs to make it very efficient, very cost effective, and so on, right? And not lose any performance, right? So that's really important. Something else that is pretty cool here is that we can change the number of answers here. So you see in the parameters, we can change the max responses here. So if I do that, I'm just going to ask Code Bison, which is Cody, which is the Google LLM for code generation. We see that now we asked 4 answers, and we can see here we have 4 drafts. And so they have slightly different, like small differences. Some of them have comments and stuff like that, right? But they are all pretty good.
Yeah, I think the other thing to also add it is at Cloud Next, which just happened 2 days ago. We actually launched a 32K token size. So Adrian, if you can probably drop down the menu. So for both Text Bison as well as Code Bison, along with Chat Bison, you now have a 32K context window. So absolutely massive. You can generate a extremely long lengths of code, along with user to process extremely large number of documents, if that is one of the use cases you're looking at,
Yeah.
right?
So I didn't use this one because we cannot have multiple responses if you use the latest one.
Yeah.
But if we take a look as well, like something interesting, of course, is when you do all of this, then you have the code that can be generated for you. And so you can just copy that and use in your application. You have the code that is generated for you. All right. So those are Google LLMs, right? But I said that we don't just have Google LLMs. If I go to Model Garden here, where you have the list of all the models, you can look for Stable Diffusion. That's just an example that people like, right? Which is an open source model. And most of the model here, they have a notebook, right? And so the notebook is really interesting. I'm just going to show you what it looks like. It enables you to deploy the model and do some tests directly from a collab environment. And so you don't have to like spin up anything. You just use that, and you have the whole documentation. You have all of the snippets of code that you need to run. And at the end, you can basically just try the model. Here you have the prompts, and you can just change the prompts, run that in the collab environment, and you will have the results. So it's basically very easy. But if that's even too complicated, there is even something even simpler. If I go back to Model Garden and I look for Stable Diffusion,
I think it's the wrong search tab.
I misclicked.
Yeah.
The
notebook is also for, let's say, for example, if you want to fine tune Stable Diffusion using techniques like Dream Booth, etc. So we have a very standardized way of doing this. So you don't have to depend on other third-party methods or unsafe methods to perform fine-tuning. There's actually a very structured way through which you can follow in the notebook to use any of the latest state-of-the-art methods to fine-tune LLMs or vision models like Stable Diffusion itself. Yeah.
And so a simple way to use Stable Diffusion as well is to deploy, right? Some of the most famous models, you have a deploy button, and it will deploy it in an endpoint on a machine that you have. So you select the machine, you can save. It takes a couple of minutes to deploy. So I'm just going to show you the result. In model registry here, I deployed a Stable Diffusion model here. And you can just look at you can just see the endpoint. You have some sample requests. You can just hit it from here as well, and you have the results here. So very simple and easy to use. You can integrate all of that in your MLOps and so on. But I'm just going to show you. We don't have a lot of time, but yeah, I just wanted to show you the equivalent to Stable Diffusion is actually Imagen, that is the Google one, and it's actually very quick, right? It generates multiple results. Here you see we have the parameters at 4, so it will generate 4 results, and we can just say, okay, I want to create an NFT abstract form in the Fidenza style, right? For example, and it should generate 4 NFTs. You will see how quick it is using Imagen compared to, that's why I'm not showing Stable Diffusion, because it's pretty quick, it's pretty slow. So yeah, you have the 4 results here. That's how it works. You can just play with it. It's very, very easy to use. You have a prompt guide as well to use it in your own application. Okay, so those are the main components of Vertex AI, right?
Maybe before we move on, if you can just go back to Model Garden.
Awesome.
Yeah. So in fact, at Cloud Next, we just announced within Model Garden our latest additions with, so if you just click on Show All, yeah, the drop-down menu, yeah, Show All.
I don't see.
Right. Yeah.
Oh, sorry.
So we just announced our latest models for Llama 2, for Code Llama, which actually just got released last week. Along with that, we are also pre-announcing Claude 2 by Anthropic directly within Google Cloud. So you can use any of these LLMs as well. And as you know, Llama 2 and Code Llama have also beaten many state-of-the-art benchmarks for a lot of the standardized tasks, right? So you can actually just deploy them directly to a Vertex endpoint within minutes and get started to using them straight out of the gate, right? So it's quite straightforward that way. Yeah. So,
and so very quickly, I'm just going to show a last thing around GenApp Builder. So GenApp Builder is for developers to create applications very quickly. And so what you can do is to basically deploy an application for search or chatbot and ground it in factuality with like specific docs or databases. And so if I create a new app here, it's very simple. You can create a search app and you can give it a name. You select the region, and then you can create a new data store to give the data. So like documentation of your own company, like products, SKUs and stuff like that. I'm not going to do it because it takes a few minutes, and I did it here. So I created here a Dap Builder test where basically I fed to this application document like reports from the crypto state, right? So I imported two big reports, like one from Messari and one from Chain Analysis. And then just to show you what it looks like, you can just ask questions, right? It deploys the application like that. So you can just have an API to ask directly the questions and it will answer, a little bit like what we've seen before. So we can say something like, what is the developer activity in 2023? And automatically, I think it should realize that we are talking about crypto because I gave him like crypto data. So yeah, so it says, okay, the core crypto developer library usage is increasing, highlighting steady growth in the dev community. It gives you where in the documents they found this kind of like quotes, and it used GenAI to summarize the document, extract the interesting information, and then generate the answer for you. You can even ask a follow-up. How will it look like in 2024, for example? And it will, that's kind of like uniqueness of Google, is to be able to ask follow-up questions. So yeah, as block space becomes more affordable, not speculative, and so on. So it explains a little bit why it thinks that and the different documents that it uses to make this assumption.
I think the one thing to highlight here is also the zero-touch approach, where literally you can just get started very quickly. You don't have to worry about creating embeddings, using a vector database, and tweaking the performance to get the best results, etc. So we automatically manage that entire end-to-end pipeline for you, and we optimize the entire indexing process so that you can automatically fetch the best results right out of the box.
Yeah. And I think like just based off these two documents, so it doesn't have a lot of words because it only have two documents, but based on these two, I think it pretty nails the question of what are the biggest threats for crypto in 2023. But yeah, so that's it for me. Hopefully it gives you an idea of, okay, what are the tools that Google have, how it works, how it looks like. And then now we're going to see with Abhishek a little bit more complex stuff.
Awesome. Thanks, Adrian. Maybe I can just share my screen. So I think we can touch a bit more in terms of how do we actually productionize this and build a lot more complex use cases, right? So I think, as Adrian just shared, the typical usage of LLMs is basically you have a user, there's an API, and the API is basically hosting an LLM. You go to an interface, ask a particular question, it generates an answer for you, right? So that's the typical usage pattern. But there are some more uncommon patterns, but more common these days. And some of them are what we have explored here today, and I'll be showing you a demo in terms of one of the things that we have done, right? So pattern number one is what we call as a chain, or not a chain, more as an agent with tools. So what it basically does is uses an LLM as a reasoning engine. So and based on that, it invokes different tools, like for example, Google search, or it basically fetches some code, or it basically then generates some SQL data, or it could also just query any database or any other external API itself, right? So that's what we call as a React pattern, and we'll just touch upon it a bit more as well. The second pattern is basically to use an LLM to generate multiple answers and then feed the all the different chunks of answers generated from various sub LLMs to a final LLM in order to generate the final answer, right? So this is something that enterprise search, which Adrian just showed, uses, where it actually uses an LLM to first retrieve and fetch the relevant chunks of information from different documents, and then finally feeds these chunks to a last LLM, which then forms the answer, right? So this is like an answer forming LLM. The third pattern is what we call as a chain, which is where it actually uses the outputs from every LLM subsequently into the next step, right? So essentially, if you want to do more complex tasks, chain pattern is what is quite interesting. And we can achieve this through this framework called as LangChain. So LangChain is an open source framework library that connects to a variety of different LLMs. Of course, in our use case, we're going to share a bit more in terms of how you can use Palm 2, but you can also use it with models from Hugging Face or any other providers as well, right?
Maybe just to say that chain does not have anything to do with blockchain. They use chain, but it's not really clear why. Maybe we can.
Yeah, absolutely. And the good thing is LangChain also has integrations to other third-party data sources like Google Drive, Confluence, Jira, or any database, etc. Right? So it can connect. It has different webhooks. It can build knowledge repos. Right? So that's the good thing about using LangChain, and it's become quite famous over the past few months. You can see the GitHub stars increasing exponentially, essentially. And basically, what we are essentially trying to share here is more on the agents and the chains sort of approach, where we basically take in a natural language question from a user and try to generate SQL code from that particular natural language statement itself, right? So there's some concept around user intent understanding and then code generation for data analysis involved in this case. So the way we have done this is through use an agent. And the reasons for that is something that I can share a bit more when we show the demo itself, right? So the core idea is to use an agent as a reaction plan itself, right? So how it works is, let's say, for example, if my question is, aside from Apple Remote, what other device can control the Apple Remote that it was originally designed to interact with, right? So standard LLM will basically just answer and say iPod, which is definitely wrong, with no prompting techniques itself, right? Then we have certain other prompting techniques like chain of thought, which introduces this thing called let's think step by step. So it actually tries to break down the problem into multiple stages and then answer it. But you can see even this prompting technique is not great in this particular use case, right? The third technique is basically act only, where it tries to invoke different APIs or different tools in order to answer certain questions. And again, in this particular use case, as you can see, it returns the answer yes, which is definitely wrong because it's unable to create a plan itself, right? So the final technique that we use is something called react or reasoning plus action, right? So what it basically does in such use cases is it decomposes the question into thoughts. And then based on this thought, it actually invokes certain tools and then takes the answer from the tool to generate a particular answer, right? So let's say, for example, the thought that it generates from this question is it needs to search for Apple Remote and find the program it was originally designed to interact with. So how does it actually do that is by calling Google search. So it searches for Google search on Apple Remote. Once the search result is in, this is the output from Google search, essentially. So this is then fed to the next stage where another LLM basically figures out what it needs to search for, or essentially something like that. So this step keeps happening till the time it figures out an answer. And once the answer is there, it basically gives you an answer saying, let's say in this case, it's keyboard function keys itself, right? So that's the high level idea in terms of how we have essentially built this demo itself, right? So maybe I can quickly hop on to the demo to show you how it actually looks like. So what we did is Google Cloud offers BigQuery datasets for 7 major chains, and definitely the major one being in that is Ethereum. So these datasets are public, and you can actually use these datasets because they have live blockchain data. It's updated in real time as well, right? So we are actually going to use that dataset, but we are going to ask questions in natural language and let the LLM figure out an answer for us itself, right? So what I'm just going to do is add in certain tables that I wanted to use. Again, you can skip this step as well. It's not really needed. I'm just adding it in to ensure that the speed of code generation is faster. But let me copy a question that we can ask itself, right? So sorry, just give me a second. Yeah, I'm just pulling up my question. Sorry, there's some bandwidth issue. Maybe we'll just try some other question in the meantime, right? Like, for example, what is the wallet address with the highest number of transactions, let's say? Like, this is a very simple question. Let's see what it basically comes up with, right? So once I click submit, it starts to think, right? So the very first thing it does is it actually loads the 3 tables into memory. Once that is done, it actually decided that it needs to answer from the table transactions itself. And then based on that, it then starts executing the next steps itself, right? So you can see that it is still running. Yeah. So once it's done, based on that particular table, it generates a SQL query itself. So you can see that the query is now being executed on BigQuery. Let's just give it a couple of seconds again. Yeah, once the query is done, you can see that the results are loaded, and finally it generates the answer, which is this particular wallet address, right? Again, if you would like to verify, you can put this on Etherscan and check it out as well. But this is essentially the rough idea of how it works. So maybe we can try another question, which is like list the wallets that have sent a transaction of more than 10 power 25 way, right? So let's run this query. The good thing with this sort of a approach, agent-based approach, is let's say in the middle, if it encounters a query that has a syntax error or is unable to actually fetch the results from, it can actually go back and regenerate an answer for this, because again, it's an agent, so it can think step by step and basically take those decisions on the fly itself, right? So you can see in this case, like the query that was generated has some error, right?
Again, the reason is too big.
Correct.
It's value.
Correct. So then it modifies the query in order to change it. And again, the next query it also generated also has another error, which is that it could not find a column called wallet address. So then again, it runs a query checker, creates a new SQL query, and then the final query that actually ran, you can see that it fetched a wallet address for it. So now you can see the list of the wallet addresses that have sent a transaction more than 10.
So there is just one.
Yeah. Oh, okay.
And there is just one. Yeah.
I think it's this one.
Is this one?
Yeah.
And the wallet is basically the transaction that is funding the Ethereum Foundation, right? So it's the only transaction that has more than 10 million ETH or something like that.
Yeah.
So yeah, Ethereum Foundation back in 2015. You can check it out as well. And one of the reasons I think that is interesting here is that why do we put the price in way? Is actually because if you put ETH, it doesn't understand that the value is ETH, and it cannot convert ETH to way. It doesn't really understand that. But it's something that could be added pretty easily to the agent, right?
Correct.
Saying, hey, as a context, the way is X amount of ETH and so on, and then it will be able to do it. It's just that this demo was built by Abhishek that is very busy. Didn't have time to really make it perfect, but we had a lot of fun to play around and find some cool queries to be able to show, but it's definitely not perfect, right?
Yeah. Again, this is a very, this field of text to SQL, natural language to SQL is still in infancy, right? This is a very experimental stage, but the good thing is the potential is massive, where everyone can have insights extremely quickly, and you don't really need to be technical in order to gain these insights. That's actually putting power back into the hands of everyone, essentially. So that's actually massive when you look at it from a wider perspective. Yeah. So yeah, that's pretty much how this demo is crafted. And yeah, I do see some questions which we can answer later on during the Q&A session, but I'll just pass over the time to Pranav. Yeah.
Perfect. Thanks a lot, Adrian Abhi. That was a very interesting and mind-blowing demo sets. So I think just to close off, want to share a few things in terms of how Google can help you in your GenAI journey. We see a variety of customers and builders and developers who might be across a variety of stages in their GenAI journey. You might be just starting to figure out how you can use GenAI. So we can help you there. We can come and share in terms of what specific use cases are relevant for your specific company, developer, use case, customers as well. If you already have a sense of use cases, we can come and further help you out in terms of what's the best way to build it, and all the way to like helping you prototype, deploy, manage, run it more efficiently. As Abhi mentioned, there are a few ways we can help you optimize from a compute perspective as well. So happy to also help in the final way of helping you deploy and manage this. So that's what we had to share. Before we move on to Q&A, for any of you who might be keen to do a 1:1 follow-up, since for the folks who have joined, we want to offer this special thing. Please scan this QR code and express your interest. Somebody from our team will follow up for a deep dive 1:1 to understand more about what you're looking to do and where we can help. I'll leave this screen on, and meanwhile, we can go to the Q&A, Abhi.
Sure. Yeah, maybe let me start from Simon. Simon has a couple of questions. So I think the first one is, when can we fine-tune Bard or Gemini? Gemini is still in process of being deployed, so probably once it's launched. But Bard, essentially, again, since it's an enterprise product, you cannot fine-tune Bard, but the underlying model which Bard uses is called Palm, which is the exact same model that Adrian showed. And you can get started on fine-tuning it as of today as well. So all you need to do is go to Vertex AI. And within Vertex AI, you can basically go into GenAI Studio, and there's an option called Tune a Model. So it's very straightforward. You can click a tune model, and you can see that there's even multiple methods of tuning. Like one is LoRa, which is obviously supervised tuning, but there's also RLHF-based tuning, which has shown extremely good methods, right? So all you need to do is select, let's say, supervised tuning. You can choose which base model you want to tune. Is it text model? Is it code model, chat model, etc.? So you can tune any sort of a model, and you just choose which region, and it kickstarts a pipeline. So it's very straightforward. All you need is about 100 to 200 samples for most downstream tasks. But the main interesting thing is, because of the way our architecture is designed, like the adapter layer and the frozen layer that Adrian shared, we don't actually charge you anything to host a tuned model, right? It's absolutely free. It's just the one-time cost that you need to tune the model, which again is probably for 1 or 2 hours. You just pay that GPU usage. But other than that, the inference cost from a tuned endpoint versus an untuned endpoint is exactly the same. There's no cost difference at all. Yeah. So that's because of the way we have designed our architecture. Yeah. Awesome. Hope that answers the question, Simon. Yeah. How do new models get into Model Garden? Is it possible to add fine-tuned models by companies there? Absolutely, Robin. We can do that. I think the best way to do that is to contact the sales and the account team that you're working with. There are some internal processes that would need to be done. But again, we are looking more at integrating many third-party and open source models, specifically task-specific models, right? So if you have any foundational models that you're either building from scratch or fine-tuning, we can host it on Model Garden. Yeah.
How many are there right now? There are a lot, no? Like
Yeah,
18?
we have about 50 to 60.
50?
Yeah, but we have a lot more in pipeline as well.
Yeah.
So yeah, the main thing why it's in pipeline is because unlike Hugging Face, where anyone can just go and upload a model, but that also has a lot of drawbacks, which is you don't know which model can actually be used for commercial purposes, but that's the fundamental business of Google Cloud. So we ensure that before any model is published on Model Garden, we have the correct model cards, the license for it, etc., so that any of GCP customers who are using these foundational models actually have commercial license to use this in production, right? Yeah, so that's basically the thing, but yeah. How does Vertex AI make it easy for developers to deploy inference endpoints with auto-scaling GPU workers like runpod.io? That's a great question, Fabian. Vertex AI is a completely serverless solution. Well, technically not serverless, there is servers, but we call it an auto-scaling, similar to GKE, Google Kubernetes Engine. You can basically specify the min number of nodes, max number of nodes, and you can auto-scale your endpoints itself. You can also specify based on what metric you want to auto-scale, like CPU utilization, memory utilization, etc. The other thing is on the other side, which is, let's say you have an endpoint, but there's not a lot of traffic to that endpoint. You want to cost save to that particular endpoint. We also have cool tricks where you can basically deploy multiple models to the same endpoint to massively save on costs as well, right? So Vertex AI is a complete MLOps solution. So definitely we do provide full inference pipelines there as well. Yeah, hope that answers your question. Is it possible to build pipelining around models in Vertex AI? Absolutely, Konstantin. You can do that again. So Vertex AI has this concept. I am still sharing my screen. So maybe if you can see my screen, there's a concept called pipelines here. So what pipelines essentially is basically Kubeflow pipelines or TFX, depending on what runner you use. But we can support multiple different varieties of pipelines itself. So for example, you can see, like, for example, one of the pipeline job that I have here is for tuning Imagen, which is our image model. So basically you can reuse all your Kubeflow pipelines that you've probably written, or if you want to switch to TFX, you can absolutely do that as well. And we automatically scale the different stages for you. Yeah.
And then I think there is
yes.
another is ask if live, and if so, is it possible to customize access to the chains? I think it was built internally for fun for this demo to showcase as well. But we're not going to open the access to everyone.
Yeah.
Not with the way it is right now, but it's pretty easy to build, right? Like it's basically using a long chain, as you've seen, using the different LLMs that we have, and then the BigQuery datasets. So if you want to build something like that or play around with something like that on another chains, it's very much possible. We can help you to do that.
Yeah.
As long as you have a data, like the data on BigQuery or any kind of data source,
yeah.
That should be all right.
Yeah. Awesome. I think there's a question in the chat as well.
There's one more on the Q&A tool that came up.
Okay. Yeah, I think it's the same question. Yeah.
Yeah, same question. Yeah.
Vector database. Yeah, absolutely. There's multiple ways, multiple different vector stores on GCP as well, right? Like, for example, the very simplest one is, let's say if you don't want to handle the entire embedding creation or storage of vector, etc. What you can basically do is use enterprise search as a retriever. That's the most simplest way. We in fact have LangChain integrations as well with enterprise search. So you can just look at LangChain enterprise search and you can find the different retrievers for that as well, right? So let me probably just quickly pull that up as well. Sorry, I'm just gonna take over the screen. Yep. But yeah, you can use enterprise search as the default retriever and a default vector database. But this is actually not what we see as well, right? Like, for example, we see customers with extremely high volumes of queries coming in per second. So we actually have our own native vector database that has always existed from almost 2 years ago within Vertex AI that we call as matching engine. So Vertex matching engine is the most scalable vector database in the world, in fact. And we use it internally for a lot of internal Google search stack, YouTube search stack, etc. So matching engine leverages this algorithm called a scan, which is extremely quick to search for the best vectors, as well as preserves the recall or the accuracy of the vector search itself, right? Whereas all the other vector databases in the market currently use an algorithm like HNSW, which is very quick, but it sacrifices accuracy in order to be very quick, right? So you can look at different benchmarks and you will find that scan, which is the algorithm behind matching engine, is actually the best and the most scalable way of doing vector search. The third way is, again, to simply use a Postgres database. Within Google Cloud, you can use either AlloyDB or Cloud SQL, and we actually have PG vector support directly inbuilt, so you can generate embeddings, store embeddings directly from AlloyDB itself. Yeah, so those are the three options currently available. Yeah, and all of them have LangChain integrations. Yeah.
Jeff had some questions up front in the chat.
Around credits.
Credits.
Further up.
Oh, GPU resources. Yes, absolutely. I assume this is for fine-tuning or deploying. If it is a model that would require GPUs, then yes, you can, while deploying the model to an endpoint, you can select which VM or which machine type you actually want to deploy to, and you can choose the accelerator that you would like to reuse for that. Yeah.
And I think then the next question around the URL of the Q&A demo for the document, right, of Generative Builder, there is no, I mean, we could externalize the link, but I think it's 5 minutes, not even 5 minutes, 2 minutes. So you just replay the video and you go in Generative Builder, you create a new app, you give a name, you select a data source with, I don't know, 10, 20 PDFs, and that's it. You deploy 2 minutes and you have the API, and you can even have the preview that I showed. You just ask your questions and you see how it works. It's using Google search and use basically LLM to synthesize and give you all the answers. So you can use natural language querying. Very simple. So if you want, just scan the QR code that Pranav sent or showed, and happy to run you through it.
I think one more question in the Q&A too.
On Q&A.
Yeah.
Sorry, I'll just put that up.
I think you should answer the question about
Yeah.
About pipelining. Is it possible to write some customer nodes for it, or is it only pre-created? So basically, Konstantin, how pipelining works is it spins up whatever machine type that you have basically written as part of your pipeline code itself, right? So it actually spins up only that particular machine type in order to solve the different stages. So you can actually choose different machine types for different stages. So for example, if you want to train, if you want to evaluate, etc., so you can choose different machine types for it. Assuming that's the question, if I seem to have missed the intent of the question, please feel free to unmute yourself and maybe clarify it. Yeah.
Yeah, if it's possible, what I was asking about, you showed this pipelining tool in your UI, and I see there's nodes connected between each other. And is this nodes is a custom function or some kind of microservices, or is just like a machine with pre-configured software that solves some task and to provide a result of the solving to next node in the pipeline?
Yeah.
And
so, oh, sorry, go ahead.
Yeah, and could customer create some kind of custom nodes to deal with specific tasks they need?
Absolutely, absolutely. So those are the nodes are actually just a visual representation of like the functions within a let's say a pipeline code that is being invoked, and you can absolutely write your own custom pipeline components. Absolutely, but I would say the easiest way to get started with it is to use the default package components that either Kubeflow provides, or there's also a separate Kubeflow, Google Cloud, Vertex AI specific components, which make it a lot more easy and abstracted away. And you can only basically build on top of that. But yes, if you want to write your own custom components, absolutely you can do that. That would just be a function of your framework there. Yeah. Yeah. Awesome.
I think there was one question on the credits part. So just to close off, we have something called as the Web3 Startup Program. You can just like if you Google Cloud Web3 Startup Program, it's a great program. A lot of the Web3 companies are leveraging it actively. It has a combination of credits, almost up to 200K over 2 years. But not just that, also has like specific training and resources, expert sessions, and benefits also from the ecosystem. Like there are several benefits from Solana, Polygon, Base that you can leverage on. So please check this out. So this is a great way for you to get onboarded and benefit from this program, and also start building with us and leveraging all the great AI platform that we have shown today. So yeah, this is how you could leverage credits from us.
I think there is another question on Generative Builder, how to access it. So let me
just pasting the link. Yeah.
Oh, you paste the link. Okay,
you can try this out. Yeah.
Yeah, I think so if you go on the burger menu at the very left of your Cloud Console, at the very bottom you have AI, and should be Vertex AI and then Generative Builder.
Yeah.
You should have access to it. There is no waitlist or anything. It's GA.
Yeah, it's going undergoing a rebranding, so it'll be called Vertex AI Search and Conversation. So it'll be part of Vertex AI as a one suite. But yeah, currently it's decoupled within the menu. Yeah.
Yeah, everything we've shown you can build, right, with the tools that are GA. It's working pretty well.
Yeah.
Perfect. I think we're also on time, and those were the questions. Awesome. Thanks everyone for joining. We'll also within few weeks post this on YouTube as well. So if you want to share with any of your teammates, colleagues, please do so. And thanks again for joining us. We will keep you posted for the next session as well. Thanks a lot, folks.
Thank you.